Hey everyone, it's EchoLynx. When you open this room, you might see a video at the top. I removed it on my page, just for this demo, using the browser's inspect tools. If you still see it, feel free to ignore it. Everything you need is below. Let's kick off with what is networking. Networks are simply things that are connected. Think of your friendship circle. You're all linked by shared interests and activities. You'll see networks everywhere: a city's public transport, the national power grid, chatting with neighbours, even the postal service moving letters and parcels. In computing, it's the same idea, just with devices. Your phone exists to connect and access things. So do laptops, security cameras, traffic lights, and even farming sensors. A network can be as small as 2 devices or scale to billions, because networks power everyday life. Gathering weather data, delivering electricity, deciding who has the right of way. Understanding networking is essential for cybersecurity. Take the example with Alice, Bob, and Jim. They've formed a small network. We'll come back to how and why that matters in a bit. Now, answer the question at the bottom. What is the key term for devices that are connected together? Type network, press submit, and boom. Task 1 complete. Let's roll straight into the next task. Task 2. What is the internet? I'm going to skip straight to the bottom because the diagram here makes it click. The internet is a series of small networks connected together to create one massive network. Here's a small network. Here's another. And another. When they link up, that's the internet. I skipped over this earlier, but you should still read it. It shows a small network where Alice is the connection point, so Jim and Bob can reach Zane through Alice. It's a solid warm-up example, but I like the big diagram best. The middle section covers the origin of the internet, a quick pass through ARPANET and the birth of the World Wide Web. Not mission critical, but worth a read. At the bottom, they distinguish between private networks and public networks. Each colored zone is a private network. The links between them are public networks, effectively the internet. We'll dig into how devices identify themselves, IP addresses, next. For now, remember, lots of small private networks connect through public networks to form one giant network. Question: who invented the World Wide Web? Answer: Tim Berners-Lee. Press submit, and you're done with task number 2. Now task 3, identifying devices on a network. To keep a network tidy, devices need to identify themselves and be identifiable. Just like people, we can think of 2 identifiers, a name that can change and fingerprints that don't. For devices, the name is the IP address and the fingerprints are the MAC address. Let's start with IP addresses. An IP, Internet Protocol address, is a label a device uses on a network. It isn't permanent. Your laptop can have one today and a different one tomorrow, and the old one might later be assigned to another device. The format you'll see here is IPv4, 4 numbers separated by dots. Those 4 parts are called octets, each ranging from 0 to 255. Only one device in the same network can actively use a specific address at a time. Otherwise, they clash. Remember, there are private and public networks. On your home network, your devices talk to each other using private addresses like 192.168.1.74 or 192.168.1.77. When they reach out to the internet, they're represented by a single public address on your router, the one your ISP gives you and bills you for. That's why 2 different machines on the same home network can share the same public IP while keeping different private ones. As the world filled up with devices, we started running out of IPv4 addresses. There are about 4.29 billion possible. That's where IPv6 steps in. IPv6 looks different and supports a mind-boggling number of addresses, which solves the shortage and brings some efficiencies. You'll see both versions in the wild. Now the MAC address. Every network interface, the little chip that lets a device talk on a network, has a MAC Media Access Control address. It's 12 hexadecimal characters split into pairs with colons, like a 4:C3:F0:85:AC:2D. The first half identifies the vendor that made the interface. The second half is unique to that interface. Vendors typically burn this into the hardware, which is why we compare it to fingerprints. You can't really change it on the chip, but you can spoof it in software so the network thinks you're using a different MAC. That's useful to demonstrate why trusting MAC addresses for access control is fragile. Hit View Site at the top to see the demo. The demo shows a hotel Wi-Fi that checks MAC addresses. Alice paid, so her packets pass. Bob didn't, so his packets get dropped. If Bob spoofs Alice's MAC, the router believes Bob is Alice and lets him through. That's the scenario you're about to run. Okay, let's do the practical. In the demo, copy Alice's MAC address exactly, 00:12:32:29:33:39. Set Bob's interface to use that MAC, spoof it, then try the site again. Once traffic goes through, the page reveals a flag. Copy the flag exactly as shown, usually in the format THM something. Close the demo tab when you're done, come back, and paste it in the last answer box. Now answer the questions and submit each one as you go. What does the term IP stand for? Internet Protocol. Press Submit. What is each section of an IP address called? Octet. Press Submit. How many sections, in digits, does an IPv4 address have? 4. Press Submit. What does the term MAC stand for? Media Access Control. Press Submit. That wraps Task 3. Once you've submitted everything, let's roll into Task 4. Task 4. Ping, ICMP. Hit View Site to open the lab. Ping is a simple reachability test. It sends an ICMP echo and waits for an ICMP echo reply. The C4 you're seeing just means send 4 pings. It's optional. The question asking for the syntax wants the basic command, not the -C option or the output. Question: what protocol does ping use? Answer: ICMP. Press Submit. Question: what is the syntax to ping 10.10.10.10? Answer: ping 10.10.10.10. Press Submit. Now, in the lab, run the ping to 8.8.8.8.8. When the page reveals the flag, copy it. Question: what flag do you get when you ping 8.8.8.8? Answer: paste the flag you just saw. Press Submit. Nice. Task 4 done. Let's roll into Task 5. Continue your learning. Intro to LAN. I have a YouTube video that walks through the next room. Super important as the next step in basic networking. Check out that video on my channel or click the link on your screen. If this was helpful, give it a like and subscribe. Once you've done that, you've finished Task 5 and the What is Networking room from TryHackMe.